Okay, this is the solutions video for worksheet 11.1. I'm not going to do all of these. I will do one sample from each section, and then you guys should be able to figure out the rest of it on your own. For section 1, find the delta H of the reaction using the below H values, using the H values. Using H values, what that means is potential energy. Okay, the potential energy values. And what were those? Remember, we calculated those in your notes. They look like this. Okay, so those are the potential energy values, and they gave that to us here. Okay, so all you have to do is this. Again, you look at your equation, your formula rather, delta H of a reaction equals total H sub potential energies of the products minus total potential energy of reactants. So we start on this side. Okay, so delta H of the reaction, remember these are your products. Delta H of reaction, you need to write it out like this, equals the total of this. Total of this is going to be, we'll do it in parentheses like this, 4 times NO, which is going to be 4 times 90, plus 6 times negative 286. Minus 4 times, notice I'm taking my time here, I'm not rushing this, okay, and you shouldn't either, negative 46 plus 5 times 0, 5 times 0, okay, that's how you set it up. When you do this math in here, let me see if I already have the answer for that. Yeah, okay. When you do this math in here in your calculator now, 4 times 90 plus 6 times negative 286, I'll actually do it because I'm not going to do all of these problems, so just 1 second. Okay, let's go ahead and do this. 4 times 90. Oops. 360 plus 6 times negative 286 equals negative 1356. So this is going to be negative 1356 minus, well, 4 times negative 46 is, well, let's do that. Minus 4 times negative 46. Negative 184. Okay, again, negative times a negative is a positive. Okay, so it's negative 1356 plus 184 for a grand total of negative 1172 kilojoules per mole. That's your answer. That's how you do that. Nothing difficult about it. You just have to be really, really careful when you set this up with your negatives and your positives. Okay, you guys can do the next two. I will do now number 2. Number 2, you find the delta H of the reaction, same thing, except what we have to do is we have to look at the we have to count up the bonds. Okay, we use the bond energies. So we break the following. One, 2, 3 NH bonds times 4 of them, right? 4 times 3 NH bonds, so 12 NH bonds. 12 NH bonds. We break 5 O2 bonds. Those are double bonds. And we form, let's see, we form 4 NO double bonds and 6 times 2 OH bonds, so that's going to be 12 OH bonds, right? Because look, here's an OH bond here and there's one there. And we've got 6 times these 2, right? Because there's 6 of these molecules. So 12 OH bonds. Okay, so now let's look at our values. Let's see what are our values. Yeah. So we're going to say 12 times NH. NH is back here. Where are you there? No, there you are, 391. 12 times 391. And 5 times your OO double bond. OO, so that's a single. OO double, 495. Okay, now we're forming these bonds, so that's going to be 4 times a negative NO double bond. NO double bond 607. And 12 times a negative, remember negative forms, right? Negative forms, OH. Why did I use negative? Because forming bonds releases energy, that's why. Okay, negative 467. Negative 467. Okay, that equals the following values. Ready? Positive 4,692. Positive 2,475. Negative 2,428. And a negative 5,604. If you add all of those up and total them, you get delta H of the reaction equals negative 865 kilojoules per mole. Now, because we've only got 1, 2, 3, 4, 5 more problems to do on this worksheet, I'm going to go ahead and let you solve the rest. I think using these examples, if you watch them, if you didn't get it the first time, you can go back and rewatch. But I think it's pretty self-explanatory what we're doing here, okay? We're just calculating the amount of energy needed to break the bonds and how much energy is released when new bonds form, all right? And go ahead and finish the rest of those. Make sure you do your POGL as well.